Hello everyone and welcome to tonight's stream. We are continuing with 1.3. We're doing the section exercises. So we're on page 39. This is Algebra and Trigonometry. You can download the book. The link is in the video description. This is part of OpenStax. OpenStax is a Creative Commons effort to create books that you can use and download for free, basically. It's under Creative Commons 4.0. Okay, so let's just get right into it. Number one, what does it mean when a radical does not have an index? Is the expression equal to the radicand? So I haven't done this book in over a month, so I'm going to have to go back and look at the does not have an index. Go back at the reading here. So let me see here. Okay, so then, yeah, so we have so this is the radical. This is the radicand. And this is the radical expression. Okay. Okay. The principal nth root of an a written is this. So this is n of a, where n is a positive integer greater than or equal to 2. So, for example, 2 root a is the same thing as this. And in the radical expression, n is called the index of the radical. So basically, if you wanted to cube root, like let's say you have 8, and then you wanted to square root it, so that means it's going to be 2 root 2, but if you wanted to cube root it, so that's 3/8, that's going to be 2. Here we go. That's a cube root. There we go. So what does it mean when the radical does not have an index? Is the expression equal to the radicand? So if it doesn't have an index, this is the index. So basically, if it's just this is equal to square root. So for example, root 2 is equal to root, and let's see, a. So for example, if we're going to go the square root of 4, that's going to be 2. And is the expression equal to the radicand? So the expression is going to be the square root of the radicand. So basically, the radical expression, root a, is equal to okay, so basically, the radical expression is equal to square rooting the radicand. All right, so let's see how you felt about my explanation here. Okay. So then there's triad sections. Odd answers. Here we go. 1.3. When there is no index, it is assumed to be 2 or the square root. The expression would only be equal to the radicand if the index were 1. So yeah, basically what I said. Yeah, I would say my answer matches up. All right. Now, just kind of pin my, there we go. The answers are in the back in C1. All right, so let's continue now. Okay. Every number will have 2 square roots. What is the principal square root? Every number will have 2 square root. What is the principal square root? All right. The principal nth. The principal nth root of a is a number with the same sign as a that, when raised to the nth power, equals to a. The index of the radicand is n. So the principal nth root of a and this is on page 36. It's the definition. Okay. The principal, let me read the question one more time and then every number will have 2 square roots. What is a principal square root? The principal nth root of a, written as n root a, is a number with the same sign as a that, when raised to the nth power, equals a. The index of the raised is n. So if we have every number has 2 square roots, so what is the principal square root? I would say 2 root is the principal of, because 2 root a, so, and that's going to be here, times 2 root a is equal to a, which is also the same thing. Okay. All right. The associative properties state that the sum of the product of multiple numbers can be grouped differently without affecting the result. This is because the same operation, this chapter 1.1 or 1.3. The principal square root is a non-negative root of the number. The principal root is a non-negative root of the number with the same sign as a when raised to the nth power. So basically, yeah, the top. All right. Now, definitions aside, let's get into it. Now, we're going to start doing some fun stuff. What is the square root of 256? Okay. All right, so that's 16. All right, 7. What is root 4 times 9 plus 16? Okay, so that's going to be root 100, which is equal to 10. So real quick, you have 9 plus 16 is 25, times 4 is 100, which the square root of 100 is 10. All right, 9, 196. What is that? It's probably like 14 or something like that. Yeah, it's 14. I knew that because 225 is 15. So I just went one more down. So that wasn't hard to figure out. All right. Root of 98. We're simplifying. Okay. So I can't just like give you the decimal point. We have to break it down to its simplest form. So we have to decompose 98 into a simple, what can we do here? Let's start breaking it down. So we have 9 times, let's see here. Let's work it backwards. We're gonna start dividing it by 2 till we get. So it's not divisible by 3. 98 divided by 4. Nope. 98 divided by 6. Nope. 98 divided by, fine. So in cases like that, so we have 98 divided by 2 is 49. And then we know that's 7 times 7. So that's going to be 2 times 7 times 7, which is equal to 7 root 2. Not bad. Okay, and 13. We have 81 over 5. So to simplify that, we can probably pull... maybe 9 1/5. Let me think about this. How to do it? Because we can. There's a 9 up there. If we pull this out, let me try this. So the key here is to get the same number, which is let's see here. 9. If I can see here, can I pull a 3 out maybe? So let me think about this for a minute here. So square root of 1/5, root 1/5 is equal to 0.447, right? Second root. So then we have the value here is 4.02. So we have 9 times 0.447. 9 divided by 0.447. 9 times 0.447. That's how we're going to do it. Okay. So here's what we're going to do. We are going to do this. We're going to go 9 times 9 times 1/5. And then afterwards, let me just... See, I was able to figure that out because I wanted to get the same value. The weight of it would have to come out the same. So then we are getting now... which is equal to 9 1/5. Okay, and then by multiplying that out, you would still come out with the same 4.02 roughly. Okay, let's just check where we're at right now. Check a couple of answers. All right, 1.3. So let me just see here. I just have to pin my position in the book. There we go. Okay. Let's check some answers. We have 5 is 16. Good. 7 is 10. Good. 9 is 14. 11 is 7√2. Good. 13 is 9 and √5/5. Which, yeah, basically they just did one more thing. So basically, you can do this. Let me just do this. So, let's see here. This is equivalent to this, 9 over √5. It should be. Let me check that real quick. And yeah, that's correct. So basically, it's just like saying this: 9 over 1 times √1/5, and then you just combine it, or actually 1/5 can be written as this: 1 over √5. So yeah, and then from here we're just gonna multiply both top and bottom. This is called rationalizing the denominator. And so we're gonna have 9 and √5/5. It gives you the same result. So this is all the same numbers. All right, moving on. Okay. All right. We have, so that was 13, 15, √169 plus √144, which is going to be 13 plus 12, which is 25. So 12 times 12 is 144. 13 times 13 is 169. Square rooting those numbers gives you 12 and 13. Add them together, you get 25. 17. All right. You have 18 over √162. All right. So that comes out to... Sorry, I sneezed there. I think I managed to mute it successfully. But anyway, let's keep rolling here. I'm still sick. All right. So we have 162. So that means we have 18 over... 162 is 2 times 81, which is equal to 18 over √81 times √2, which is equal to 18 over 9 √2. Scratch that. So then we have 2 root 2 multiplied by the denominator, and then we end up with being root 2 over 2 root 2, which is equal to root 2. So yeah, we had 2 in the, yeah, so that's just to make sure we did that right. Yeah, that looks right. Okay, so that should be the correct answer for 17. All right, we'll check, of course. I just want to get a few more done here before we go there. 19. We have 14 root 6 minus 6 root 24. All right. So in order to subtract them, they both have to have the same of the root. You can't subtract a 6 root 24 from a root 6. So let's try 14 root 6 minus 6 root, we have 2 root 2 root 6. Since we have 2 times 2 is 4, times 6 is 24. So then we're going to scratch these and make that a 2. So then we have 14 root 6 minus 12 root 6, which is equal to 2 root 6. All right? And yeah, then we have 21. All right? We have root 150. All right? So then we can try dividing it by 5 or by 2. Let's see what numbers we're going to get. So let's try by 5. So we can get root 5 times root 30, which is equal to root 5, root 6, which is equal to 5 root 6. All right? Okay, let's go check some answers. Okay, we're going to go in the back of the book. And 15 is 25. 17 is root 2. 19 is 2 root 6. 21 is 5 root 6. All right. So far, so good. All right. Now, we were 21, right? Okay. 23. So we have root 42 times root 30. So what happens when we do this, we can actually merge the roots. We can combine it like this. We can say 42 times 30. Now, we want to actually pull some numbers out of there. So let's actually start decomposing them. Well, we can pull some 2's out. Let's just write down all we have here. So 2. So 42 divided by 2. So that's going to be times 3 times 7. So 3 times 7 is 21, times 2 is 42. And then we have times, so we're just going to say this right here. This is 42. And then this right here, we have 5 times 2 times 3. So that's going to be our 30. And then look at that. We have 2 2's and we have 2 3's. So that means we're going to get 2 times 3 times... So because we have doubles, we can pull a single out. So 2 and 3 we pull out. We have times 7 times 5, which is going to be 6 root 35. Okay. Then we have 25. Okay, we have 4 over 225. Okay, so that's so yeah, well, we can actually pull, well, let's decompose it first. So we have 2 times 2, and then we have this is going to be, what is it? 15 times 15. Right. So we can pull out, oh, we can just do that, which is equal to 2/15. All right. So yeah. Cool. 27. We have 360 over 361. Okay. So the 361 is a tricky one. Decomposing it, like 360, okay, so we have our 6s and our 10s. So we'll start with the easy portion, the top first. So we have 6 times 6 times, we have 5 times 2. 6 times 6 is 36, times 5 is going to be, whatever. It's going to be 5 times 2 is 10, so that gives us 360. So that's the important part. Now, the 361... Okay, 361. Well, let's just start taking... It can't be 2, 3... It can't be 2, it can't be 3, it can't be 4, it can't be 5, it can't be 6. So we have to use numbers like 7, 13, 11, you know. Let's try divided by 7. Nope. Divided by 11. Nope. 13. 361 divided by... Alright. 361 divided by 17. And... Okay, 361 divided by 21. So here's the thing. Every time you divide 361 divided by a number, right? Let's say if I divided by 21, I get 17.19 ... So right away, I know that I can't do anything more than, it doesn't make me any much more sense to try to divide it by like some other number, because I know that the numbers, if I'm going to decompose it, I'm gonna have to, it's gonna be between 1 and 21, because at least the number has to be doubled or a multiple of some of those numbers. And I tried, so you know, like 1 through 5 doesn't work, 6 doesn't work, 7 tried, that doesn't work, 8 obviously will not work, 9 will not work, 10. By the way, the reason I know 9 doesn't work is because 3 doesn't work. If this was divisible by 9, it would have to be divisible by 3, and it's not divisible by 3. So we just have to take our, essentially what we're looking at is we need our prime numbers to try to get it. So you want to try 7, 11, 13, 17, and 19. Divided by 19. That's what it is. 19. So, and that's how I knew, right? We tried 21, 17, no match. Let's try 361 divided by 19. It's 19. So, it's a, this is a prime number, 19 times 19. But we can pull some good stuff out of here. So then we're going to pull our 19s and a 6 out. So we're going to get 6/19 over root 10. And yeah, we can't decompose root 10 into anything. So 6/19 root 10. That looks right to me. All right, let's check some answers. 23. Okay, we have 6 root 35, yes. 2 root 50, 2 root 50, 2/15, yes. And then we have 6 root 10 over 19. Yeah. Okay. So far, so good. All right. And let's see here. All right. Let's try 29. 29. We have 8 over 1 minus root 17. So we're going to have to rationalize the denominator. And then the way to do that is... Okay. I think we can just break this up. Let's see. 8 minus 8/17. Is that right? I'm not sure if I can do that. Give me a minute. I need to remember. I don't think I can do that, actually. Right. Let me actually do the number real quick. Eight divided by 8 divided by root. Actually, no, that won't work. All right. So we have to rationalize the denominator. I think we just have to multiply it by a positive number. Yeah, I think that's how we're going to do this. Let's try this. We're going to try something here. We just flip the sign. Okay, if I did that, and the bottom gives us 1, and then we have 1 times 1 is 1, 1 times 17 plus root 17, negative root 17, negative root 17, and 17 times 17 is going to be negative root 17. So then, which it was, right, that's fine. We can keep the negative root 17. Sorry, it will be it'll be negative 17. All right, that's correct. So these two would scratch, and it's going to be 1 minus root 17. So yeah, notice how I did that. So now 1 minus root 17 is equal to now the 1 minus 17. Okay, but so first I'm just going to keep the demonstration. So I've established that. That's very convenient for us because we're going to really rationalize it now. So then the top is going to be 8 times 8 root 17. And the bottom is going to be 1 plus 17, which is equal to, let's move some of this stuff around. That's going to be 8 plus 8 root 17 over 18. And then, so we can simplify this a little bit. So we can take out, make this 2. This is going to be 4. Sorry, not 2. I'm taking out the 2. This is going to be 9. So then, so we have 4 plus 4 root 17 over 9. Okay. So notice it's quite a different number, but here's how you know if what I said is true, right? Let's just do a quick proof. What is 8 divided by 1 minus root 17? So we're going to do root 17. So root 17 is equal to 4.123. We're just going to keep that. So we're going to say 8 divided by 1 minus 4.123. Okay, so that's going to be 8 divided by negative. Oh, and I should carry the negative. The negative was from the 17, so it's negatives up there. So that's going to be 8 divided by 3.123. So if I did this right, 8 divided by 3.123, it should come out to negative 2.5616 ... Right? Okay. Actually, you know what? Because I'm just gonna 562 ... We're gonna keep it to the same three numbers. Now, if we were to take 4, so we're gonna say root 17 is, we established that it's 4.123. So 4 times 4.123, that's 16 plus another 4, that's 20. So that's going to be 4 plus 4 root 17 is equal to 4 plus 4 times 4.123 ... over, and then the negative is here in the 9. So that comes out to 20.492 divided by 9. So that comes out to roughly the same. There's rounding involved, but it's negative 2.276. Just like my dog's calling me. So I'm back. So it should be, it'll be pretty close. So the question has to do with the couple of rounding times that I did it. How close is it? Because the numbers aren't precise, but they're pretty close. So it should work, I think. Let me see here. Well, let's find out. 29. Let's see here. 1 plus 17 root 2. So they got a different, hang on a minute. This is 29. 1 plus 17 root 2. So yeah, I did not get that same answer. Let's see where I went wrong. So they had 1 plus 17 over 2. Okay, let me try this. So they did rationalize the denominator. If it's 1 plus 17 up top, that means that, let me read the question again. 8 over 1 minus root 17. I'm going to have to work on this one, figure this one out. Don't agree with what I got. Now, it would work if, hang on a minute. It would work if the 9 was an 8. That's the only difference here. The 9 has to be an 8. So that means it would have had to have been 16. Oh, okay. I see where I made my mistake. So I went toward, like I said, my numbers weren't precisely right. So that's, and then I was like, yeah, it might work, but I wasn't sure. I see where I made my mistake. We have 8 over 1 minus root 17. So then we're going to say 8, and then we're going to multiply this 1 minus root 17 times 1 plus roots. You can multiply top and bottom by any number you want. Yeah, so if we did that, 1 times 1 actually we might but let's actually, instead of multiplying it by positives, let's do it by negative. Let's see what we get there. One times 1 is 1. And we have minus root 17. We're going to have plus root 17 times 1, negative 17. Then we have, oh, wait a minute. So it would be, oh, we would have 2 negatives. So it would be negative 17 again. And then it would be plus 17. So we would end up, 1 minute, plus 17. So we would end up with 1 minus 2 root 17 plus 17, which would be 18 minus 2 root 17 if we did it that way. Which doesn't really help us. It just, we kind of expanded it in a way that we were trying to get rid of the denominator. So let's multiply it by positives. Okay, so then we have 1 minus root 17 times 1 plus root 17. All right, 1 times 1 is 1. Okay, and then we have plus root 17, negative minus root 17. And then we're going to say minus 17. That's where it was. That's where I went wrong. I added that plus the 17. It's going to be negative 16. All right, that's perfect. So everything's going to work out now. These two get scratched, and these two, it gives me negative 16. Okay, that's good. That's great. So now the top, you have 8 times 1 plus root 17, which equals to 8 plus 8 root 17. Okay, so now we have this. We have 8 plus 8 root 17 over negative 16. So that's going to be 1. This is 1. And this is going to be 2. So, and then the negative comes out here. So we're going to have negative. We have 1 plus root 17 over 2. Alternatively, we can take the negative in. We could also say this. Minus 1 minus root 17 over 2. So that's the same thing. I'm pulling out the negative or putting it in. Either way is fine. All right, so then verifying it one more time. Yes, so that's good. So that was my mistake. I took the 1 and added it to the 17, and that's how I got 18. Instead of adding the positive 1 plus the negative 17, which would have given me negative 16. Okay. Hey, that's great. And that question was 29. All right. Let's do now 31. Cube root 128. I'm not good with cube roots to the top of my head. 3 times 3 root 2. But I know a few tricks that we can use. So if the 3's on the outside, we can bring it in, right? If we pulled it out, we have here, we have 3 times 3 times 2, and then we have the cube root here. So we can do that. And then so we have 3 times 3 is 9 times 2 is 18. What can we do with that? Alternatively, can we scratch the 3's? It's only if it's a power, not a multiplication. All right. Actually, we can do this. Wait a minute. We don't have any cubes here, though. So let me check the other one. We have 128. So that's probably like cube root 4. No, close. Okay, it's 216. 128. Let me see here. Okay, and I need a minute to really think this one through. Well, what numbers can we get with 128? And if we can get like a cube, then we can pull it out and then leave the remainder in there. Probably, I'm guessing. Okay, so. All right, so here's what we can do. This one, we're going to say 4 times 4 times 4 times 2. So then we can scratch these, and we're going to take the 4 on the outside. So this is now 4, and then we're going to say root 2, 3, 2, like that. So basically, the 4 we were able to pull out, and then the 3 cube root of 2 remains. Or we can also say this. We can say 4 and 2 and a third. 2 to the third power, basically. We can do that. Which would be, would multiply that out, and that would be see, I don't know if we can do that, because if we multiply that out, make it 8 to an 8, a cube root 8 would be 2, and that's not the right number. So it's like this. Let's keep it to avoid confusion. We're gonna keep it like that. Because if it was 4 times 2 is 8, and then we added the cube root to 8, that would give us 2, which is not what the number is here. Right. Okay. And then the top one here plus. Oh, no, this is great. I understand now. This is what we were going for. So we can add them. 7 and with 3 cubed 2. So 7 times cube root of 2. All right, let's do, let's check that one, and then, because I'm running out of space here, we're going to do 33 next. Let's see here, 7, yeah, the book agrees. There we go. So now we have 33. All right, and that's going to be 15 cube root 4, 125 over 4 cube root 5. Yeah, we should be able to just take that part out. And then, so we can go like this. 15 times, we're going to merge them. We're going to say cube root 4 of 125 over 5. Like that. And then that's going to be here, yeah. 5, so that's 25. So that's going to be here 15 quadruple root of 25. And can I simplify that further? Can I make that a 5? Or an 1/8 maybe? So what we can do this is this way. We can do this. 15 quadruple root over 5 squared. And if we did that, we should just be able to scratch these two, make this a 2. So 15 root 5. I think that's how we're going to do that. Yeah. Let's see here. Yeah, book agrees. All right. So that's good. Now we have 35 root of 400x to the 4th power. Okay, so this is a cube, so we could think of it this way. This is, you could think of it 400x to the 4th power. So that, what we can do is going to be x. But if we did that, we're losing the whole cube. Okay, this is getting too confusing. Instead, we're going to do it like this. We're going to say root. We have 2 times 2 times 2 times 5. No, I meant. So that's 10 times 4 is 40 times 2 times 5. Actually 400 should just be let's see here. So that means we have 2 times 2 times 2 times 2 times 25. Yeah. Okay. So we have 4. That's fine. So then we have, and then we have times x times x times x times x. So let's just start scratching the doubles. We're going to lose a 5, and we're going to lose 2 2s, and we're going to lose 2 x's. And then this thing is gone. So now that leaves us, we have 2 times 2 times 5 times x times x. So that comes out to 20x squared. which, you know, if you think about it, 20 times 20 is 400, and x squared times x squared is x to the fourth power. So yeah, that should be fine. All right, 37. All right, we have 49p. Okay, so that's going to be here 7 times 7 times p. And treat the p just like an x. It's just they're usually giving us different numbers. So that's going to be 7p. 7 root p. The p is just like a root x. Or we can make it, this is also, we can go like this, 7 times half p. All right, and 39. M to the 5/2 root 289. Okay. So what we have is m is to the 5th power square root. So, which is fine. I don't think we want to put it back into the square root, though we can if we wanted to. If we wanted to, we can do this. I'll show you. Well, let's actually do that. Let's see what happens. We're going to put the m in here. So we're going to have 289. And we're going to have m to the 5th power. Okay? Well, we can drop the... when we do that, we can... m should be m times m times m times m, leaving one m. So that's going to be m squared. Wait a minute. So that's going to be 289 m times m times m times m times m. So we can drop 2 of the m's and then pull out the rest. Yeah. So we just have to pay the toll. Because these are powers. Yeah, that should work. Hang on a minute. Oh, no, that wouldn't work. Just like when you have... If you had 5 2's, right? The result would be 2 root 2. Or 4 root 2. If we were to pull it out. If this was... m was 2... So that means we would leave 2 2's in there. We would pull 2 2's out, and the last one would be root 2. So we have basically m squared with root m. We can do that. And as for 289, we just have to figure out what we can do with that. So we're going to say m squared root m times, and then 289 is going to be 289 divided by 3. Nope. 89 divided by 17. That's what it is. 17 times 17. Okay. So that means we have 17m squared root m. Okay. Yeah, that's what I'm getting. All right, let's check that real quick. Alternatively, it would be 17m 52. 37. 7 root p, yes. 20x squared, yes. And 17m squared root m. Yep. So yeah, there it is. Okay, good. So they're both the same numbers, but 17 with m 5/2 is just not simplified. So not completely simplified, in other words, because the 289 part is. All right. Let's try 41. We have 3 root ab squared minus b root a. Okay, so that's 3b root a minus b root a. And then this is going to be here wait a minute. Root A, which is equal to, can we subtract that? That should be, yeah. It's going to be 2b root A. So there are 3 sets of b root A, and we're taking away one of them. So that leaves 2b root A. 43. You got to be careful with adding, because like if you were, it's not like you're taking away like a 2. I mean, it could be, but the thing is that's a multiple. So yeah. Anyway, so that's how that worked. 43. We have 225 over x to the 3rd power over 49x. They're all on the square, so this is good. So then we have 15x to the 3rd power times 15. And then we have 7 times 7 times x. Let's get rid of the x squared. So then we're going to pull out the 15 and the 7, and we're going to pull out an x. Because we had x squared, so we had to pay the toll. We had to drop one of the 2 15s, one of the 2 of the 7s, and one of the 2 of the x's. Okay. Root 50 y to the 8th power. So that means it comes out to 5 times 5 times 2. So 5 times 2 is 10 times 5, and then y to the 8th power. So then we're gonna, so basically we have 8 y's. We're paying 4. Remember, you have to pay half whatever you want to take out. So that gives us 4. And then this is gone now, so we just have the root. So then we have 5 root 2, and then y to the 4th power. Or we can put the y last. There we go, y to the 4th power. Let me just do that a little better. Okay, 5 y to the 4th power, and one of the 2's it was left behind, so that's how we get the root 2. All right, that's 45. 47 root 32 over 14d. All right, so then we have 32, so that's going to be 8 times 4 over 7 times 2d. Let's break this down further. We have 2 times 2 times 2 times 2 times 2 over 7 times 2d. We're going to scratch the 2's, and then we're going to pay 2 2's to get out of here. So then that gives us 4 over 7 root 7d. And then we're going to multiply this by 7d over 7d. So that comes out to 4 root 7d. D looks terrible. D over 7d. Okay. So that's rationalizing the denominator. Okay. Okay, let's take a look real quick here. 41. Yes. 15, yes. 45, yes. And 47, yes. Okay, so far so good. All right. Now, 49. We have root 8 over 1 minus root 3x. Okay, well, let's multiply this out by 1 plus root 3x over 1 plus root 3x. What does that give us? So 1 times 1 is going to be 1 plus root 3x minus root 3x, and then plus, by the way, in case you forgot the polynomial multiplication, I'll show you real quick here. So we have, if it's x, or a plus b times a minus b, you're going to get a squared plus 2ba plus b squared. Let me check that. A times a is a squared. Actually, no, sorry. Plus b squared. That's what you get. And that's because a is going to be a squared, and then minus ba plus ba plus b squared. So that's how you end up with that formula. Let's see here. So then, yeah, a squared. It will, if they were both pluses, it would be 2ba. So, anyways, right. So then we have that, and then minus 3x, because we multiplied this out by itself. So this is equal to 1 minus 3x. And then the top, we have root 8 plus a times 3x over 1 minus 3x. Okay, and make sure that's right. That's right. Okay. So that we have root 8 plus 20. I'm just going to do it down here. Root 8 plus root 24x over 1 minus 3x. Okay. That should be right. Let me check that real quick. 49. All right. And that is, but it's not complete. Let's simplify it further. So 8 is going to be is equal to 2 times 2 times 2, which is equal to 2 root 2. So then we have 2 root 2 plus, and then we have 2 root 2 plus, so then 24 is equal to, root 24 is equal to 8 times 3, which is equal to 2 times 2 times 2 times 3. Wait a minute here. Yep, that's right. And so then what we have here, which is equal to, we can still pull out 2 root 6. So then we have 2 root 6x over 1 minus 3x. Okay, so that's a more simplified, more complete. And that is the correct answer. All right, that was 49. All right, and let's do 51. W 3 seconds over 32 minus W 3 seconds root 50. Okay. So in order to do any kind of additional multiplication, we're gonna have to simplify the square root. So 32 is gonna be 2 times 2 times 2 times 4. So that's 2 times 2. So that's 2 times 3 2's is 8 times 2, 16 times 2 is 32. Okay, and then we have here, we might have to multiply the 2 out in order to be able to do any kind of addition or subtraction between them. But it's not a fraction though. So that might not work. I gotta think about this for a minute here. And the 50 is gonna be 2 times 5 times 5. Okay, so we end up with a 3 root 2 and a 5 root 2, or 4. So let's see what we get here. W 3 2. Well, maybe that's just the point. So we end up with 4 root 3 minus W 3 2 with 5 root 2. And the fractions don't match, so yeah, like I think that's all we can do with it. Let me check. 51. No, they managed to do much more than that. Let me figure this out. So the W's are in fractions. Well, let's see here. So the W's, what else we can do here? So the W is basically this. W squared over like this. Sorry, no, I got it backwards. It's to the third power being squared. So in that case, we can leave a W in and pull one out. So we can go W root W3 minus W times, oh, this is 4, and that's 5. W root 2. Now, let me look at this again. So from here on, what they did was they just did a subtraction, and they ended up with a negative W root 2W, which would work if this 3 was a 2. Which it is. Okay, that's where I screwed up. Okay, I see here. Let's do this over. Okay, let's fix this one more time. I made a mistake early on, and that's what threw everything off. Okay, so then we have... so the W 3 2 is equivalent to root W to the third power. And that is also W root W. So we're going to combine this. We're going to say W root W, and then we have, so we're going to scratch 2 2's. So that gives us 4, and that leaves a 2 in there. Okay? And then over here, we have the same thing. W root W, and then we're going to scratch one of the 5's, and then that gives us a 5, and it leaves a 2. So then right now we have 4W root W2 minus 5W root W2. So that gives us negative W root W2. Okay, and that is the correct answer. So I made a mistake. I put the 3 instead of a 2. There was no 3 there, and it was a typo. That's what threw the equation off. But the rest of it's, yeah, this is fine. Right, and 53. Okay, 53. Root 12x over 2 plus 2 root 3. Okay, and so we can do this. This is going to be 2 times 2 times 3 x over 2 plus 2 root 3. So then this is going to be 2 root 3x over 2 plus 2 root 3. We're going to drop the 2's. So now we have root 3x over root 3. We're going to drop that, and then we're going to get x. All right. So yeah. Check that real quick. All right. That was 53. No, I made a mistake there. Just a second. Okay, I'm back. Just my uncle needed me for something. Alright, where did I make the mistake? Oh, it would have been 1 plus... Okay, let's do this one more time. Let's check that one more time. Root 12x over 2 plus 2 root 3. Okay, so the first part would work. So we have... So the first part was right. We have 2 times 3x over 2 plus 2 root 3. We'll get rid of the 2's, but that means it's a 1 there. That's where I made a... I was going too fast there. So 3x over 1 plus root 3, and then we just have to rationalize the denominator. So we're going to multiply this out by, let's see here, so then, I think it's just 1 plus, I think we're going to do plus root 3 over 1 plus root 3. And if we do that, so that's going to be 1 times 1 is 1, root 3 times, so wait a minute, 1 times 1 is 1, and then it's going to be 1 root 3, so it's going to be 2 root 3. No, I don't want that. I actually need to make it negative. So, because we were trying to get rid of that. Okay. So then the denominator is going to be 1 times 1 is 1, negative root 3 plus root 3, and then minus 3. Okay. So, yeah, and then the top is going to be, we're going to have at the top, we're going to have root 3x And then we're going to have minus 3 root x. Is that right? Seems to be here. Okay, and then over negative 2. And is that right? Yeah, because 1 minus 3 is negative 2. All right, and then we're going to pull the negative out. So we're going to say negative, I'm going to say 3x plus 3 root x over 2. So I think, let me check that. All right. Negative 3x plus 3 root x over 2. All right, good, that's correct. Okay, good. And of course, here we go. We have 40, wait a minute. We're now in 55. Let's just start a new page. 55, we have root 125 times n to the 10th power. Okay, so 15 times 15 is 125, so we have 15 times 15, and then we have n to the 10th power. So basically what we have here is that we pull out a 15, and then n to the 5th power. All right. Remember, you leave the half behind. If you have a double, you can only pull half out of the radical. All right, so then we have 57 root 81m 61m squared. Okay, so we know this is 9 times 9 times m over, what was that, 17, I think? 17 times 17? Or is it 21 times 21? 17 times, it's 19 times 19, I think. Yeah. So then we have 19 times 19 times m. So let's scratch these, and then we're going to scratch these. So then we have 9/19 and root m. Okay? And then we're going to multiply that by root m. So that's equal to 9 root m over 19m. All right. Okay. And now in various math classes, some teachers care about rationalizing the denominator, others don't. It kind of depends upon what you're focusing on. But that's an important tool to know, that when you have to simplify something, that's considered part of simplifying. Although you could ask, do we have to rationalize the denominator, you know? It's like, okay, all right. 59. 144 over 324d squared. Okay. So we have 12 times 12 over, I don't know what we can do with 324, but we're going to find out. 324, we're going to divide that. Let's see if it divides by 8. No. 24 divided by 6. So that's 54. So then we have 2 times 3 times 54 times d. So what can we do with 54? Let's divide that by 2. That's 27. So now we have 12 times 12 over 2 times 2 times 3 times 27 and times d. And you can see where we're going with this. So that means the 27 is going to be 3 times 3 times 3. Okay, So that breaks it down very nicely. Everything breaks down very nicely. So we can pull a 12 out, and then we can pull out 2 3s, and we can pull out, in a minute here. So yeah, we can pull out, so we have 4 3s and 2 2s. So you can pull out 1 2, and we can pull out 3 2s times 3, which is 12. Wait a minute, 3 times 3 is, so no, that's not 12. And we pull out a D. And so then we're going to say this is going to be 2 times 3 is 6. This is 2. So we have 2/3 D. Yeah. All right, let me just check that. 140. Yeah, that should be right. Okay. And let's verify the answers so far. 55. Okay. 15 and to the 5th power. Hang on a minute. I'll come back to that in a minute. 57, 9 over root m over 19. That's correct. And 2/3 d. So 55 is, what was it, 125? It's 5. The end is correct. It should be 5√5. Let me check that real quick. 55. Let's see, so 15, 15 times 15 is 225. I'm sorry, not 125. That was my mistake. Okay. So 5 times 5 times 5 is 125. Let's correct that. Times 5, so that's going to be, let me just rewrite the whole thing here. So that, we're going to get 5 n to the 5th power root 5. Or n to the 5th power of 5 root 5. Okay, so that's that. All right, and got the 59. Let's do 61. 61. You have root. So quadruple root of 162 x to the 6th power over 16 x to the 4th power. Okay, so to break even, we need to have 4s. But we can still pull some stuff out. We would just drop the number of the root. So this is x to the 4th power? Yeah. Well, for starters, let's simplify this a little bit. So we have 162 x squared. We're going to drop the x to the 4th power and scratch those and divide it by 16. So then 162 divided by 2 is 81. Okay, so this is equal to 4 root 2 times 9 x squared over 2 times 2 times 2 times 2. All right. So then if we have 4 4s, and so that's so we should just be able to pull out the 2. So we have, and the 9s could also break down to 3. So that's 2 times 3 times 3 times 3 times 3 x squared. And then to the 4th root over 2 times 2 times 2 times 2. So we have to pay a total of 4 to pull something out. So we can pull a 3 and a 2 out. And then that's going to be here. And then the x, we can drop the square and just make it a square root. X squared, we drop 2. Drop it down to square root. So then we're going to say... so we're going to say... What's left in here? Say root x and 2 cube root to the 4th power, which should be, yeah. So that's like what, 2 1/8 or something like that. That's going to be an interesting question. I don't think that's complete. 61, 59, 61. So 3 and 2 is right, and then we have... Oh, we don't have to simplify the x. I went a little step beyond. So what I did with the x is that I dropped this and I paid the toll here, so that's just root 2, so that's root x. This is also the same thing as doing this. 3 over 2 for x squared 2. So yeah, I think that's what they left there. Yeah, or yeah, 2x squared. Yeah. But essentially, I just went a step beyond. But it looks neater to keep them in the same and the denomination. So that's fine. We're gonna do it like that. And 63. Let's do another page. All right, and okay. We are in 60. What is it here? We are in 63. Yeah. 3 128 z to the 3rd power minus 3 minus 16 z to the 3rd power. So what? Right away, let's just pull the z's out. Z root 128 minus, and then we can pull the negative out. We're going to put plus z. Because it's a cube, 3 times, the negative will remain. So double negative is a positive. We pull that out. So that's going to be 16. And then we just want to break it down to where we can add this. So 128, that's, what was that, 2 to the 6th power? The 7th power. So that's going to be 8 root 2. So that's going to be z8 root 2 plus, this is, just a second. Sorry, my dog was barking here. He's still a little worked up. He's seeing some dog outside my window here. All right, but let's finish this up real quick here. 63. I'm going to have to probably end the stream a little early and then finish up the rest next time. The 16th power is 2 times 2 times 2 times 2. So what we have here is, So let me think about how we're going to do this here. Let's see here. 8. So let me think about this. So if we wanted the 16 in there, it would have to be 2 times 2 times 2. So that's the problem. So on the one hand, we have 4 2s and we have 7 2s on the other hand. And I'm trying to figure out how we can do this. But we might not be able to do anything with it. Just do it like this then. Okay, fine. We're going to say z8 root 2 plus 4z. Yeah, that's pretty much it, what we can do here. I mean, alternatively, we can do some, let me think here. Yeah, that's fine. Let me just check that one more time. So it's going to take 7 2s, so that means we can pull 3 of the 2s out. We drop 3, so that's 6, leaving 1 behind. And 2 to the 4th power is 16. Oh, there's one other thing. I forgot one more rule. I made a few mistakes here, and this is going to explain what's going on. This is still there. You still have to pay the penalty for that, so that's going to make it work. Okay. So what we're going to do here is... All right. So 128 is... So we have z, and then 3 with 2 to the 7th, plus z root 2 to the 4th. All right. Okay. So that means... Hang on a minute. Okay, so that means... And if we wanted to simplify the ends, the m's, I think we can just scratch the 3 and then pay that. Two. Okay. So if we were to do this, okay, let's try that. So in other words, if we pay 3, we pull 1 out. So that should be z, and then we can pull 2 root 2 plus, and here we can pull z4 root 2. That should be good. We're going to use that. There we go. Make it more legible. Okay. So then we should be able to work with this. Yeah, that's going to be z6 root 2. I think that's the answer. 63. Z6, oh, right. The one that we left in there retains this property. So the ones we were able to pull out, so that's just it. So yeah, you pay a penalty of 3 to pull one out. But the remainder one, so we pulled 2 of the 6 out. And the last, the 7th one, remains the cube root of 2. And on the 4s, we pay the penalty of 3 to pull 1 out, leaving the 1 cube root of 2. So that's Z6 cube root of 2. All right, that's 63. All right, and okay, so let me think here. All right, well, I'm going to wrap it up for today. We're almost done. Still have a few more questions to answer, but we'll get to those next time. And yeah, I hope you enjoyed tonight's stream. I will